Chapter 11.1, Areas of Triangles and Parallelograms. So starting with the area of a square is side times side. Okay, if you let each side length of the square equal S, and you can see all of the sides of a square are congruent. So all of the sides of the square equal S. The area for the square is just S times S, which is the same as S squared. So that's the area of a square. All right, if two polygons are congruent, then they have the same area. And finally, if the area of a region is the sum of the areas of its non-overlapping parts. So for the area of a rectangle, the area is just the base times the height. Okay, so b, lowercase b, is basically just the length of the base, and lowercase h is just the length of the height. All right, now between the base and the height, you want to remember that the base and the height are always perpendicular to each other. They always make a right angle with each other. Now, some people think of the area of a rectangle as length times width, or L times W. So that's the same thing, but I think it's better to use B and H for base and height. But again, you want to make sure they make a right angle with each other. Now, for parallelograms, either pair of parallel sides can be used as the bases, and the height is the perpendicular distance between those bases. So here we have a parallelogram, and of course we see that opposite sides are marked parallel. They said either pair of parallel sides can be bases, so you can see here the top is parallel to the bottom, and they made those the bases. All right, and the height is the distance, the perpendicular distance between the bases. So once again, you can see the height and the base, they make a right angle with each other. So it also makes a right angle with the other base as well. So once again, you want to remember that H, the height, is perpendicular to the base B. Now here they're just showing you, if you start with a rectangle and start sliding these layers to one side, you can form a parallelogram. Okay, but the area does not change. You started with a rectangle and you slide these layers to one side and it becomes a parallelogram from the rectangle. So as a result, the area for the parallelogram is right here. It's the same as the rectangle. It's just base times height. Okay, so like we said, the base B are either pair of parallel sides, and the height is the distance between those two bases, but it has to be the perpendicular distance. So the area formula for the parallelogram, it's the same as a rectangle. And for the triangle, it's just half of the base times the height. Okay, so it's the same as the rectangle or the parallelogram, but you just take half. All right, and for the triangle, the base is any side of the triangle. So you can see right here, they labeled this as the base B. And the height is the perpendicular distance from the vertex to the base. So if you go to the point or vertex that's opposite the base, like this vertex point here, that distance is considered the height H. So once again, notice the base and the height, they make a right angle with each other. So we can say that the base is perpendicular to the height. And you'll notice that pattern for these figures. So right here, they're just illustrating that the area of a parallelogram equals the area of a rectangle. Remember this symbol right here? That is the symbol for parallelogram. So the areas are equal, and they're showing you why. Here in blue, we have a parallelogram, and if you draw in if you take the height, and we know it's the height because it makes a right angle here, and if you cut off this piece right here and attach it to this side, then you will just have a rectangle. All right, so if you had cut off that piece right there, then you would have this figure right here in red. Okay, and that's a rectangle, and it's the same area as the part we had in blue. So they're just showing you why the area formulas are equal. Now, for the area of a triangle, it's just 1/2 times the area of a parallelogram. Okay, you can see here we have a parallelogram, and if you just draw in a diagonal, that cuts the parallelogram in half. And then if you don't count this half, this triangle right here in blue, that's just going to be 1/2 base times height. Okay, so the whole thing, the area is base times height. You cut it in half, you get a triangle, and 1/2 base times height is the area. Example 1, find the area of parallelogram PQRS. All right, so we have PQRS, that's this part in blue, and we said the area of a parallelogram is just base times height. All right, we said that you can use either pair of parallel sides as the basis. So I have this side here parallel to this side here. All right, and opposite sides of a parallelogram are congruent. So we only need one side, or one base. All right, so this right here, I'm going to use as the base B, that's 12. And then the perpendicular distance between those two bases, that's going to be the height, H. All right, so it's pretty simple. Base times height is just going to be 12 times 4. And that equals 48. All right, there were no units on it. Otherwise, it would be the units squared. Now, this one is interesting because they gave us all the dimensions. So we can do this another way. Okay, I'll do it in a different color. We can still use the same formula, base times height. Okay, and now they said the base can be either parallel sides. So pair of parallel sides. If you look at the top and the bottom, those are parallel to each other. And you only need one of the two bases because they're congruent. So I can use this side as the base B. And then the distance between the top and the bottom, that's right here. See, they couldn't do it inside the parallelogram, so they did it outside. This distance right here, that's perpendicular to the base, that's going to be the height. So base times height, B times H, is going to be 6 times 8. And that equals 48. So you notice, even if I use different bases, I still get the same answer. All right, guided practice, they want us to find the perimeter and area of the polygon. So please pause and try number 1, and I'll give you a hint. The area for the triangle we said was 1/2 base times height. And we know for perimeter, you just add the sides. Please try it. All right, for the triangle, we said the base can be any side, but we already have the height right here. See this height, H, equals 8. And if you look at this height, it's perpendicular to this side right here. So we're going to have to use this side as the base if we use this as the height. So if the height is this here, this is going to be the base B. All right, so that's going to be 1/2 times B, which is 21, times H, which is 8. Now, to make this easy, you can certainly use a calculator, but if you have an even number, it's easier to distribute the 1/2 to that number. So I'm going to keep the 21, and half of 8 is just 4. Okay, and then that makes it simpler. 21 times 4 is just 84. And there weren't any units on that. So 84 is the area. Now for the perimeter, that's very easy. They gave us all the sides. So you just add the sides. That's 17 plus 10 plus 21. Okay, and that's 27 plus 21, and that equals 48. All right, please try number 2, area and perimeter. Remember, the area for the parallelogram is base times height. All right, so I'm going to use top and bottom as my bases. Those are parallel, so this right here is going to be my base B. And the distance between those bases is the height. That's right here. And that equals 17. So the area is just base times height. 30 times 17. And that is going to equal 510. Now, if you look at this, and you may be wondering if we can use the other sides as the bases. So if we use this as the base, we would need the distance from this side to this side. Okay, so it would be something like that, and perpendicular to that side. We didn't have that distance, so we couldn't use the 20 as the base. All right, so that's why I chose this side here as the base. Now for perimeter, we know that opposite sides of a parallelogram are congruent. So if this side is 20, this one over here is also 20. If this side is 30, this one is also 30. So adding the sides, I can do 20 times 2 because there's 2 20s. And then I can do 30 times 2 because there's 2 30s. And that's going to be 40 plus 60. Okay, please pause and try number 3, and I'll give you a hint. You first need to use Pythagorean theorem to find this side length right here. All right, so use that first. And then the area for a triangle is going to be 1/2 base times height. All right, so Pythagorean theorem, we know that is a squared plus b squared equals c squared. All right, c has to be the hypotenuse across from the right angle. So that's going to be c. A and b, it doesn't matter. I will let a equal 5. I'll let the missing side here equal b. All right, so a squared is going to be 5 squared. B squared we're going to leave as is, because that's what we're looking for. And c squared is going to be 13 squared. 5 times 5. Well, I'll tell you what, we'll do it the quick way. Solving for b squared, the opposite of positive 5 squared is negative 5 squared. I'll do that to both sides, and it cancels here. If b squared is this, the way to undo something squared is to take the square root. I'm going to take the square root on both sides. Square root of b squared is just b, and I'll do this on the calculator. I think it's 12. Yes, it is 12. So this side length here equals 12. And now we can do the area formula. All right. We said the base and the height are always perpendicular to each other, and we said the base is any side. Well, we have this height right here. So that's going to be my height h, and it's perpendicular to this side right here. So that's going to be my base b. All right. This b stands for base. This b was just in the Pythagorean theorem. It's just a coincidence that they both matched. Anyhow, we have 1/2 base, which is 12, times the height, which is 5. Half of 12 is 6, times 5 is 30. And now, the perimeter is easy. You just add the sides. You have 5 plus 13 plus 12. All right, 5 plus 13 is 18, plus 12 is 30. Now, the perimeter and area are not always going to be the same for a triangle. It's just a coincidence. Example 2, the base of a triangle is twice its height, and the area of the triangle is 36 square inches. Find the base and the height. Now, before I even go to the diagram, I am looking at this sentence right here. The base of a triangle is twice its height. And I can write an equation just based on that. Okay, the base of a triangle, I'm going to call the base B. And that says it is or equals twice its height. So that's going to be 2 times the height, or 2 times h. So already I have an equation. The base is 2 times the height. All right. And they're saying that the area is 36 inches squared. So let's write that out. They said the area equals 36 square inches, or inches squared. All right. Now, we know for a triangle, we didn't even need the diagram, but they drew it anyway. We know for a triangle, because it said it's a triangle, that the formula for the area equals 1/2 base times height. Okay, and they gave us that the area equals 36. So now what we can do is use this equation and substitute it or plug it in. All right, so in place of B, since B equals 2 times H, in place of B, I'm going to plug in 2 times H. All right, so looking at my formula here, we have 1/2, and in place of B, I'm going to plug in 2 times H, okay, because we said B equals 2H. Now that's times H, and that equals 36. All right. Now, on some of these, you might have to multiply both sides by 2. But here we have an even number. I know that half of 2 is just 1. 2 divided by 2 cancels. And then H times H is going to be H squared. And that equals 36. The opposite of squaring something is to take the square root. So H is going to be the square root of 36, or just 6. Okay, I know -6 would satisfy this equation, but a side length cannot be negative. So the height is 6. And at the beginning, we said the base is 2 times the height. So if the base is 2 times the height, that's just going to be 2 times 6. And of course, that equals 12. Now, the only thing I forgot is that the area was in inches squared. So when we took the square root of both sides, really, I should have had the inches squared under the square root. Or you don't have to write it, but just make a mental note of it. And if you took the square root of inches squared, you would just have inches. So the height is 6 inches and the base is 12 inches. Just remember, whatever units are, when they give you the area, those are going to be the same units when you have the side lengths, but you're just not going to have this part that's squared. So just remember that. Okay, please pause and try guided practice number 4, and I'll give you a hint. The formula for the area of a parallelogram is base times height. You want to plug in for the area and the height and solve for the base B. Okay, so it says the parallelogram area is 153 square inches. So in place of area, I am going to plug in 153. And I'll plug in the square inches as well for now, just so you can see the units. And the height is 17 inches. So we don't know the base B. We're looking for B. I'll leave B alone. And the height H is 17 inches. Okay, solving for B, the opposite of times 17 is divided by 17. I'll divide by the units as well. 17 inches over 17 inches cancel. 153 divided by 17, that just equals 9. Inches squared divided by inches. This inches cancels and the squared cancels, and you're just left with inches. And that equals the base B. So that is your final answer. You don't always have to write the units in your equation, okay? But it should match that you have the area in a certain type of units, and the side lengths are also in the same units. If not, you have to convert them.